Hello guys, welcome back and for the 7th day. Today we're gonna doing the fit a linear model to the data by and also we're gonna try to methods of the least the squares and fit the linear models as well. And also use the CAS and use by hand to do our questions. So first thing first, we start this question first. So we're gonna fit the line by eye. Um Clearly, we can see this is a linear relation. What is the car velocity when the time equal to zero? So you can say it's around like 18 or 17.5 meters square meters per second. So we could do is around 18 meters per second. So that's your y-intercept. And question B. So what is the slope of the line? So now we can do rise over run. So we highlight those two numbers. Okay, now we can substitution the point. So 525, 0, 18. So slope will equal to y2 minus y1 divided by x2 minus x1. So that equal to 25 minus 18 over 5 minus 0. So that equal to 7 over 5. That equal to 1.4 is your slope. Yeah. Question C, write down the equation of the line in terms of the velocity over time. So velocity equal to v and time equal to t. So what we do is we say v equal to 18 plus 1.4 t. That is the equation. Another one, which is we can use the examples here as well. Here is the data for the fitting the eye to the sky plug, student staff of the secondary ratios for secondary against the staff ratio primary school as well. So we can say ratio of primary, ratio of secondary on the vertical, primary is horizontal. So determine the equation in terms of variables in question. So first one, when you figure out the first point, so if we can figure out the first point, will be start from 0, 8. And another point will be like here, which is I think is 30 and 28. So that's good. So 30, 28, 0, 8. Yeah, once we get those two, so we can say slope equal to so slope equal to y2 minus y1, x2 minus x1. So 28 minus 8 divided by 30 minus 0. So 20 over 30. So that equal to 2 over 3. Yeah, or 0.667 or something. Yeah, that's the slope. And another one will be use the another point to figure out our A will be which is I using as 0, 8. So we can say your lines, which is we say secondary is S, primary is the P. So S equal to 8 plus 0.67 P. So that is your equation. Yeah. So for the linear regression, once we find the slope is your regression, and the intercept points, which is we're gonna use our intercept points to figure out R is correlation coefficient. So we're using this formula to calculate, to figure out our straight figures and stuff. So we just substitution into this formula and that formula to find out. And so we had the bar for x bar y, that means mean for x and y. Sx and sy, that means standard deviation. So we did this one in chapter 2. Hopefully you guys still remember, but that's okay. If not, let's try to do a quick question to understand. So we're gonna find the significant figures. So we know b equal to r times sy divided by sx. So that equal to 0.6 times 5.4 divided by 9.8. So that we can use the CAS calculator. So we're going to CAS here, so we can do control divide. So 0.6 times 5.4 divided by 9.8, so equal to 0.331. So approximately equal to 0.331. Because around 3 significant figures, so that's pretty much enough. Then a equal to bar y minus b times bar x, so that equal to 62.3 minus 0.331 times 165. That equal to something. Let's figure out this one. So 62.3 minus 0.331 times 165. So that equal to 165. That equal to approximately 7.685. So 7.685. So y equal to 7.685 plus 0.331 x, but y equal to 7.69 plus 0.331 x. There you go. So this is your doing by eye. So that's how you calculate the formula by eye as well. So now I'm gonna show you to do CAS, but stay with me. I'm gonna do it in the next video. We'll be back.